Ever wondered how your favorite earbuds are made? Let's take a deep dive into the cutting-edge tech and machines that bring these tiny marvels to life. From high-speed assembly lines to rigorous quality tests, each step ensures the perfect blend of technology, comfort, and style. Stay tuned as we uncover the secrets behind the machines and expertise that make it all happen. Design and prototyping. The design and prototyping process for earbuds involves transforming a concept into a functional prototype using advanced tools and techniques. This stage focuses on creating the physical structure, internal electronics, and software necessary to test functionality, comfort, and performance before mass production. Factories use cutting-edge technology like 3D printing for casing prototypes, PCB prototyping machines for circuit boards, and manual assembly techniques to combine components like drivers, microphones, and batteries. Rigorous testing is conducted to ensure Bluetooth connectivity, audio quality, and ergonomic design meet user expectations. Component sourcing. The component sourcing process for earbuds involves identifying and procuring essential parts such as Bluetooth chips, microprocessors, tiny audio drivers, lithium-ion batteries, microphones, and charging mechanisms. Manufacturers work with specialized suppliers to source high-quality components, often from global markets like China, Taiwan, and South Korea. Once sourced, each component undergoes thorough quality checks to ensure compatibility, durability, and performance standards before they are integrated into the final product assembly. Assembly. The earbuds assembly process involves carefully integrating various components into a fully functional product. It begins with the installation of the audio drivers and microphones into the earbud housing. Then, the printed circuit board, PCB, with Bluetooth and power management chips is connected, followed by the placement of the battery. The components are securely housed in the casing, often sealed using ultrasonic welding or screws for durability and water resistance. After assembly, the earbuds undergo rigorous testing, including connectivity, audio performance, and comfort checks, ensuring a high-quality product ready for packaging. Software installation. The software installation process for earbuds involves loading the firmware onto the device's microcontroller and Bluetooth modules. This firmware enables key functions such as Bluetooth pairing, touch controls, audio processing, noise cancellation, and battery management. The software is developed and tested to ensure compatibility with various devices, e.g., smartphones, tablets, and to deliver seamless performance. Once installed, the software is tested for stability, responsiveness, and connectivity, ensuring that the earbuds work efficiently with different platforms before moving to the final quality control stage. Quality control and testing. The quality control and testing process for earbuds ensures that every unit meets performance and durability standards. It involves several stages. First, audio testing is performed to check sound quality, frequency response, and noise cancellation. Bluetooth connectivity tests ensure stable pairing and range across different devices. Battery testing evaluates charging times, battery life, and power efficiency. Durability tests include drop tests and water resistance checks, IP rating. Lastly, ergonomics and fit testing are conducted to ensure comfort and secure fit for different users, guaranteeing a high-quality, reliable product. Packaging and branding. The packaging and branding process for earbuds involves carefully placing the earbuds and their accessories into protective packaging. The earbuds are securely packed with items like charging cables, extra ear tips, and user manuals. The packaging is designed with the brand's logo, product details, and regulatory information, reflecting the product's premium quality. The branding is consistent with the overall company image.
Manufacturing a gaming remote involves several stages, ranging from design and prototyping to mass production and quality assurance. Here's a detailed breakdown of the process. Hashtag 1. Design and prototyping. Designers create initial sketches and 3D models using CAD software. Ergonomics are a priority to ensure comfort during prolonged gaming. Integration of features like buttons, triggers, joysticks, and haptic feedback is planned. Component selection. Choose microcontrollers, sensors, e.g., gyroscopes, accelerometers, battery, and communication modules, Bluetooth, RF. Prototyping. 3D printed models to test ergonomics and button placement. Electrical prototypes are created for testing functionality. Firmware development begins to ensure compatibility with gaming platforms. 2. Tooling and molding. Injection molding design. Molds for the remote's plastic housing are created based on 3D models. Materials like ABS or polycarbonate are selected for durability. Button and component molds. Separate molds for buttons, triggers, and other movable parts. 3. Component manufacturing. PCB manufacturing. Printed circuit boards, PCBs, are fabricated and assembled. SMT, surface mount technology, is used for placing components like microprocessors, resistors, and capacitors. Plastic injection. The housing and buttons are mass-produced using injection molding. Special components. Joysticks, haptic motors, and sensors are manufactured or sourced. 4. Assembly process, subassembly. PCBs are assembled and tested for connectivity and functionality. Buttons, triggers, and joysticks are integrated into the housing. Final assembly. Upper and lower casings are secured. Batteries and wiring are installed. Quality checks ensure proper alignment and functionality. 5. Firmware programming. Gaming remotes are flashed with firmware to enable communication with consoles or PCs. Compatibility testing is conducted across different gaming platforms. 6. Testing and quality assurance. Functional testing. Buttons, triggers, and joysticks are tested for responsiveness. Wireless range and communication are verified. Battery life is tested under different usage conditions. Durability testing. Drop tests, stress tests, and vibration tests are conducted to ensure reliability. User experience testing. Devices are tested for comfort and usability by focus groups. SEM packaging and distribution. Packaging design. Retail-friendly boxes with protective inserts are designed. Logistics. Devices are shipped to warehouses or directly to retailers. Continuous improvement. Feedback from customers and market trends are used to refine designs for future iterations. Software updates may be released to improve compatibility and performance. Would you like more details on a specific stage? Or are you looking for a tailored plan for a particular type of gaming remote?
The manufacturing process of a piano involves a combination of precision craftsmanship, engineering, and artistry. It typically follows these stages. 1. Design and planning. Blueprint creation. Engineers design the piano, specifying dimensions, materials, and mechanics. Material selection: high-quality wood, such as spruce, maple, or mahogany, steel strings, felt, and other components are chosen for durability and sound quality. 2. Case and frame construction. Woodworking: the wooden frame and body, case, are crafted using seasoned wood to ensure stability and resistance to warping. Shape formation: the rim of a grand piano is bent and glued into shape using presses and clamps. Iron frame casting: the cast iron plate is molded to hold the tension of the strings, which can exceed 20 tons of force. 3. Soundboard and bridges. Soundboard: a thin piece of spruce is used to amplify vibrations. It's cut, sanded, and crowned, arched slightly, to enhance resonance. Bridges. Bridges, made from hardwood, transfer vibrations from the strings to the soundboard. 4. Action mechanism. Key assembly: white keys, traditionally made of ivory, now synthetic materials, and black keys, usually ebony or plastic, are crafted and balanced. Action components: thousands of small parts, hammers, springs, levers, are precisely assembled. Each part is responsible for transferring the energy of a key press to the string. 5. Stringing. String installation: steel strings for high notes and copper wound strings for lower notes are installed and tensioned. Tuning pins: the strings are anchored to tuning pins, allowing for precise pitch adjustments. 6. Tuning and voicing. Tuning: the piano is tuned multiple times during the manufacturing process. Voicing: the felt hammers are adjusted to ensure consistent tone across the keyboard. 7. Finishing. Polishing: the case is sanded, stained, and polished to achieve the desired finish. Assembly: the lid, pedals, and other external components are added. 8. Inspection and quality control. Final adjustments: every piano undergoes rigorous testing to ensure sound quality, playability, and durability. Final tuning. After assembly, the piano is finely tuned and inspected before shipping. This intricate process can take several months to complete, reflecting the piano's complexity and the need for precision craftsmanship.